Experiment-1. Aim of the experiment: to determine the gas produced when different salts are subjected to reagents and heat. Theory: when substances are heated, they may undergo decomposition, sublimation, gas production, precipitate formation, or other chemical changes. Treating a substance with reagents such as dilute hydrochloric acid or dilute sulfuric acid can lead to the evolution of gas with distinctive properties such as color, smell, and chemical nature. These properties aid in identifying the substance. Apparatus and chemicals. The required materials include test tubes, a test tube holder, a Bunsen burner, an unknown salt, and common laboratory reagents like dilute hydrochloric acid and dilute sulfuric acid. Procedure: 1. Place a small amount of the given salt in a dry test tube and heat it using a Bunsen burner flame. 2. Treat the salt with either dilute hydrochloric acid or dilute sulfuric acid in a separate test tube. 3. Observe and record the gas evolved according to the provided table. Make inferences based on the observations. 1. When dilute hydrochloric acid or dilute sulfuric acid reacts with active metals such as magnesium and zinc, a gas is released. Initial test observation: the gas being observed is both colorless and odorless, and it doesn't show any effect on litmus paper. Confirmation test observation: when a burning wooden splinter is approached to the gas extinguishes the flame and burns with a faint blue color, accompanied by a popping sound. Hydrogen. 2. Gases released on heating. Metal nitrates example PbNO32. Release nitrogen dioxide NO2. Metal oxides example HgO, PbO to release oxygen O2. Oxisols example K2CrO4, KMNO4, K2Cr2O7 release various gases like carbon dioxide and oxygen. Initial test observation: the gas under investigation is transparent and has no discernible odor. Additionally, it does not exhibit any reaction with litmus paper. Confirmation test observation: when a glowing wooden splinter is brought close to the gas, it reignites the splinter. Oxygen. 3. Gases released by heating. Most metal carbonates excluding sodium carbonate and potassium carbonate result in the liberation of carbon dioxide gas. Heating metal bicarbonates also leads to the release of carbon dioxide gas. Reacting dilute hydrochloric acid or dilute sulfuric acid with metal carbonates or bicarbonates also produces carbon dioxide gas. Initial test observation: the gas being examined is both transparent and lacking any noticeable smell. Moreover, it causes moist blue litmus paper to change from blue to red. Confirmation test observation: when a burning wooden splinter is exposed to the gas, it is extinguished. Additionally, the gas causes freshly prepared lime water to become cloudy or milky in appearance. Carbon dioxide. 4. Gases released by heating. Manganese dioxide, lead oxide PbO, lead oxide PbO2, potassium permanganate KMNO4 or potassium chromate K2CrO4 with concentrated hydrochloric acid results in the liberation of specific gases. Reacting dilute hydrochloric acid or dilute sulfuric acid with bleaching powder also produces a specific gas. Initial test observation: the gas under examination appears as a greenish-yellow color and emits a strong, irritating odor. When exposed to moist blue litmus paper, it initially turns it red and subsequently bleaches the paper. Confirmation test observation: when moist starch iodide paper is exposed to the gas, it changes color to blue-black. Chlorine gas. 5. When a metal chloride or ammonium chloride is boiled with concentrated sulfuric acid, a specific gas is liberated. Initial test observation: the gas being observed is transparent, lacks any distinct odor, but possesses a pungent and irritating smell. It causes moist blue litmus paper to turn red. Confirmation test observation. When a glass rod dipped in ammonia solution is brought close to the gas, it produces dense white fumes. Additionally, the gas is capable of extinguishing a lit matchstick. Hydrogen chloride gas. 6. Gas is produced in the following situations. When metal sulfides excluding Na2SO3 and K2SO3 are heated. When metal hydrogen sulfides are heated. When dilute hydrochloric acid or dilute sulfuric acid is reacted with metal sulfides or metal hydrogen sulfides. Initial test observation. The gas being observed is transparent and lacks color. However, it emits a pungent and suffocating smell, remaining odor of burning sulfur. When exposed to moist blue litmus paper, it first turns it red and then bleaches it. Confirmation test observation. 1. When a glowing wooden splinter is brought close to the gas, it is extinguished. 2. The gas causes the decolorization of acidified KMnO4 solution. 3. Acidified K2Cr2O7 solution changes color from orange to green when exposed to the gas. Sulfur dioxide gas. 7. Gas is released when dilute hydrochloric acid or dilute sulfuric acid reacts with metal sulfides. Initial test observation. The gas being observed is transparent, lacking any discernible odor, but has a distinct rotten X smell. It causes moist blue litmus paper to change from blue to red. Confirmation test observation. When lead acetate paper is exposed to the gas, it undergoes a color change and turns black. Hydrogen sulfide gas. 8. Gas is produced when ammonium salts are heated with alkalis. Additionally, metal nitrides react with hot water to release gas. Initial test observation. The gas being examined is transparent and does not have a specific color, but it possesses a recognizable pungent smell. When exposed to moist red litmus paper, it causes the paper to turn blue. Confirmation test observation. When a glass rod dipped in concentrated hydrochloric acid is brought close to the gas, it produces dense white fumes. Ammonia gas. 9. Gas is released when hydrated salts such as CuSO4, 5H2O are heated. Similarly, gas is liberated when heating metal hydroxides excluding NaOH and KOH, as well as metal hydrogen carbonates or metal hydrogen sulfides. Initial test observation. The substance being observed is either a colorless gas or vapor and lacks any distinct odor. It does not exhibit any reaction when exposed to litmus paper. Additionally, a colorless liquid condenses on the cooler surfaces of the test tube. Confirmation test observation. When in contact with white anhydrous copper sulfate, the substance turns it from white to blue. Furthermore, it causes blue cobalt chloride paper to change its color from blue to pink. 10. When metal nitrates excluding NaNO3 and KNO3 are heated, a gas is liberated. Additionally, when metal nitrates are treated with concentrated H2SO4, another gas is released. Initial test observation. The gas being observed appears as a reddish-brown color and emits a pungent and irritating smell. When exposed to moist blue litmus paper, it causes the paper to turn red. Confirmation test observation. When most potassium iodide paper comes into contact with the gas, it changes color to brown. Additionally, when the gas is introduced to green acidified ferrous sulfate, it causes the solution to turn brown. Nitrogen dioxide gas. Precautions. It is essential to work under supervision at all times in the laboratory. Always wear a lab coat to ensure personal protection during laboratory work. Exercise caution when handling chemicals as they have the potential to cause burns or other injuries. Do not directly inhale liberated gases or fumes, as they can be harmful and even fatal. Handle glassware with care and promptly report any damages or accidents to the supervisor. When burning or heating salts, use a test tube holder to hold the test tubes and maintain a safe distance from the burner. Heat the test tubes cautiously to avoid overheating, which may lead to breakage. Exercise caution when exposing the gas to a burning wooden splinter, as the reaction can be explosive. Keep in mind that many gases are colorless, odorless, and do not react with litmus paper. Always perform confirmatory tests to accurately identify the gas. Preliminary test results should not be reported without confirmation.